Okay. The next one is lens. Okay. So what is a lens? So lens is an optically transparent medium. Lens is an optically transparent medium which is bounded by two surfaces, which are bounded by two surfaces. Okay. For this one we call the lens. And see, it is made up of optically transparent medium, and it has two surfaces. One surface this side and the surface this side. So this is a lens. Okay. So if I define the lens as a optically transparent medium bounded by two surfaces, if I say it is bounded by two surfaces, is it right? Okay. If I draw like this, is it a lens? For example, so this one. So here it is bounded by the surfaces and is optically transparent medium. Can you say this as a lens? No. So the definition is not sufficient. If I say the lens is an optically transparent medium which is bounded by the two surfaces, is not enough. So among those two surfaces, or out of those two surfaces, at least one is curved. At least one is curved. That is called the lens. Okay, so how to define the lens? Okay, see, the lens is a transparent optical medium bounded by two surfaces. Out of two, at least one is curved. So this is the meaning of lens. And see, this is optically transparent medium and is bounded by two surfaces, and both the surfaces are curved. And here one surface is plane and the surface is curved, but still we call it as a lens. And this is a group of converging lenses. Converging lenses. And this is the group of diverging lenses. Diverging lenses. Okay. And see, if I extended this curve like this, so this will be another sphere. And it will have a C and radius of curvature. Okay, so for this curve, I say this has a curvature R1 and this has a curvature R2. And here R1 is not equal to R2. And for this we call the biconvex lens. Biconvex. Bi means two. Convex. Two surface convex. And here R1 and R2. R1 and R2 are equal. So we call this as an equiconvex. We call it as an equiconvex lens. Means both the surfaces are of same radius of curvature. And here this is one side is plane and the side is convex. We call it as a plano-convex. We call it as a plano-convex lens. Okay. And do you know what is the radius of curvature of a plane surface? What is the radius of curvature of plane surface? It is infinity. Okay, next one is about the diverging lenses. And see, this has a R1 and this has a R2. R1 is not equal to R2, but both the surfaces are concave. So we call it as a biconcave lens. Biconcave lens. And here R1 equal to R2. And this is called equiconcave. Bi means two, concave. Edu kade concave ada. Ille edu kade concave, but equal distance, equal radius of curvature. Okay, equiconcave. Equiconcave lens. So idike ಏನು ಅನ್ಬೋದು? One side plane ada, ಮತ್ತೊಂದು side concave ada. This is plano-concave. Plano-concave mirror. So this is the basics about the lenses. There are a variety of lenses. While studying the lens, we should know some important terms. Those are optic center, center of curvature, radius of curvature, principal focus, and focal length. I have studied same thing in case of mirrors. Okay, here what is the optic center? Say, optic center is a midpoint on principal axis inside the lens. Is a midpoint on principal axis inside the lens through which an incident ray can pass without deviation. Okay, so which is inside the lens, which is on the principal axis, And if we allow a ray of light, to pass through that optic center, so there will not be any refraction. It passes directly like this. So that's why the definition is, it is the midpoint of the principal axis inside the lens through which an incident ray can pass without deviation. Okay, without any refraction it can pass. Okay, that midpoint is called the optic center. Optic center. Okay, next one is center of curvature. Center of curvature. It is the center of sphere of which the curved surface of lens is a part. And see, in our lens there are two curved surfaces, first one and second one. If I extend this one, so there will be one sphere. Okay, here is another sphere. I can say this part or this surface is a part of a sphere, and that sphere should have a center of curvature. And this surface is also part of another sphere. And it is also having a C. I call this is C1 and C2. Okay, center of curvature of first surface, center of curvature of second surface. Is it? And next point, radius of curvature. It is the distance of center of curvature from the optic center. Optic center ದಿಂದ center of curvature ವರೆಗೂ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅದ? ಅದು ಎರಡು ಸೈಡ್, ಈ ಸೈಡ್ ಇರಬಹುದು, ಈ ಸೈಡ್ ಇರಬಹುದು. I call this distance as R1. Okay, and this distance as R2. Radius of curvature of first surface, radius of curvature of second surface. Okay, so radius of curvature means the distance of center of curvature from the optic center of the lens. Is it? Okay, next principal focus. The point on principal axis where all refracted rays meet by the parallel incidence. Okay, suppose we are allowing the parallel lines to incident on a lens. As a result, and we know this is a converging lens, as a result of refraction, they pass through like this. Okay. Right? And this is called F, where all refracted rays meet. Principal focus. Okay, and then if I say this is C, this will be F1, and this is F2. Okay, so the refracted ray may meet here. Is it? And this distance, the distance from next one, focal length, the distance of principal focus from the optic center. The distance of principal focus from the optic center. This is called focal length number 1. And this is focal length number 2. Means focal length of first surface, focal length of second curved surface. So these are the very important terms related to the lens. Next point is the position of formation of image with respect to the position of object. Okay, if you know this one, you can easily say where will be the image by knowing the position of object, and it will be helpful while drawing the ray diagrams and while studying the optical instruments. Okay, for example, here we are having a convex lens. It's a convex lens, and the midpoint of this lens, what do you call for this one? This is optic center. Usually we represent it by O. In some book they have represented it as C. Okay, somehow we should call it as optic center, the midpoint of the lens. And this is the focal length. F. Sorry, principal focus F, and the distance from O to F. This is focal length. And this distance, I call this is 2 times the focal length, 2f. In the same way, we can have the one more principal focus, so we can get one more 2f. Right? Whenever the object is placed at a large distance, at a very large distance, so for large distance, I say we kept at infinity. Okay? So if the object is at infinity, I call this is first position. If the object is at infinity, the image forms at f of the lens on other side. ಆಬ್ಜೆಕ್ಟ್ ಇನ್ಫಿನಿಟ್ ಆಗಿದ್ದಾಗ ಇಮೇಜ್ ಎಫ್ ಅಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದ. ಯಾಕೆ ಎಫ್ ಅಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತಿರ್ಬೋದು? ಯಾವಾಗ ಆಬ್ಜೆಕ್ಟ್ ಇನ್ಫಿನಿಟ್ ಆಗಿದ್ದಾಗ ಸೋರ್ಸ್ ಇಂದ ಆಬ್ಜೆಕ್ಟ್ ಮೇಲೆ ಲೈಟ್ ಬೀಳ್ತದ, ಇಲ್ಲಿಂದ ಲೈಟ್ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಬರ್ತಿರ್ತದ, ಅದು ಇಲ್ಲಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗ್ತದ. ಅಂಡ್ ವಿ ನೋ whenever the light is from the infinite distance, so that coming lines must be parallel. Okay, so now the parallel lines and the parallel lines incident or the parallel lines meets at f only. We know this basic, right? And if the object is at 2f, the object is beyond the sea. The object is beyond the sea.
2f.
Or 2f. So instead of c, here we are using 2f. 2f ಅಂತ ಹೇಳಬೇಕಾಗಿತ್ತನ. Right, when the object is beyond the 2f, the image forms here. This is the second position of image. First position. Okay, what's the position of image now? It is in between f and 2f. Now, the object is at 2f. The object is at 2f. Then where will be the image? The image is also at 2f. At 2f. And what about the size? What about the size? It is same size. And see, here you can get, by this diagram you can get the nature and size, then position of image. In first position, when the object at infinity, the image forms at f. What about the size? This is point size. What about the nature? It is real, because it is inverted image. You know when to say real image and when to say virtual image. Object image ಏನಾದರೂ ಆಬ್ಜೆಕ್ಟ್ ಉಲ್ಟಾ ಕಾಣಿಸ್ಲಾತಿತ್ತ, ಅದು ರಿಯಲ್ ಇಮೇಜ್. ಆಬ್ಜೆಕ್ಟ್ ಹೆಂಗಿದನೋ ಇಮೇಜ್ ಹಂಗೆ ನೇರವಾಗಿ ಕಾಣಿಸ್ಲಾತಿತ್ತ, ಅದು ವರ್ಚುವಲ್ ಇಮೇಜ್. ಇವಾಗ ಇವು ಮೂರು ಏನಾಗಿದಾವ? ರಿಯಲ್ ಇಮೇಜಸ್. ಓಕೆ, ಅಂಡ್ ದ ಪೊಸಿಷನ್, ದೆನ್ ದ ಸೈಜ್. ಇಲ್ಲಿದ್ದಾಗ ಏನಾಗಿದೆ? ಸೊ ಗೆಟಿಂಗ್ ಪಾಯಿಂಟ್ ಸೈಜ್. When the object is beyond the 2f, we can get between f and 2f, and in inverted real image, what are the size? It is smaller compared to this one. Now when we kept it at 2f, the image forms exactly at 2f, and what about the size? The size is same. So we are getting the same size image, means its size is same as that of object. When we kept in between f and 2f, when we kept the object between f and 2f, the image forms beyond the 2f. The image forms beyond the 2f. What about the nature of image? Real, because it is inverted one. What about the size? It is enlarged size, enlarged, or you can say magnified image. It means it is the size of image is greater than size of object. When I kept the object at f, principal focus, then the image forms at a very large distance. We can say the image forms at an infinite distance. Okay, what are the nature of the image? It is inverted, so that's why it is a real image. And what are the size? It is much more enlarged. The image is much more enlarged or much more magnified image, right? So when the object is in between f and o, what is the f? Principal focus. What is the o? Optical center. When you kept in between f and o, I call this is sixth position, the image forms. The image forms here. Okay, what's the position of image now? The image forms beyond the 2f on the same side of the lens where we are having the object. ಇಲ್ಲಿ f ಮತ್ತೆ o ನಡುವೆ ಆಬ್ಜೆಕ್ಟ್ ಇಟ್ಟಾಗ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ಸೈಡ್ ಅದನ್ನ ಲೆನ್ಸ್ ದ ಅದರ್ ಸೈಡ್ ದಾಗ ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತದ. ಅದು ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದ? 2f ಗಿಂತ ಹೊರಗಡೆನೆ ಫಾರ್ಮ್ ಆಗ್ತದ. ಓಕೆ, now what's the nature of the image? It is virtual. How do you say it is virtual? Because it is direct image. Is it? Okay, what about the size? You can compare. The size is enlarged, magnified image. Is it clear? So this is a basic thing about the lens to say where may be the image with respect to the position of object. Okay, right. And in a practical section you are having experiments with the lenses. In those experiments you will have such a type of viva questions. For example, we may ask you mention the position of object by which you can get the image whose size is same as that of object. ಓಕೆ, ನಾವೇನಂತ ಹೇಳ್ತೀವ, ಲೆನ್ಸ್ ಮುಂದೆ ಒಂದು ಪೊಸಿಷನಲ್ ಆಬ್ಜೆಕ್ಟ್ ಇರಬೇಕು. ಹಾಗೆ ಇಡೋದ್ರಿಂದ ಆಬ್ಜೆಕ್ಟ್ ಸೈಜ್ ಇದ್ದಷ್ಟೇ ಇಮೇಜ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗ್ತದ, ಇಮೇಜ್ ಫಾರ್ಮ್ ಆಗ್ತದ, ಆ ಪೊಸಿಷನ್ ಯಾವುದು ಅವ್ನು ನೀವೇನಂತೀರಾ? ಸೊ ದಟ್ ಈಸ್ 2f. 2f is a position of object by which we can get the object of we can get the image of same size. Okay, and we may ask you, we want to get the virtual image. We want to get the virtual magnified image by a convex lens. What should be the position of object? We should say the position of object must be between f and o, so that you can get the virtual magnified image. And the further part of this topic, that is optical instruments. So in that section you will study the microscopes and telescopes. So in microscope you will have object lens, and we kept our object at a particular distance. So ಅದೆಲ್ಲ ನಿಮ್ಗೆ ತಿಳಿಬೇಕಂತಂದ್ರೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಎಲ್ಲ ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕಾಗ್ತದ. Okay, and you can make a tabular column like a position of image, position of object, size of image, and the nature of image, which we did in case of mirror. ಅದನ್ನ ಫಾಲೋ ಮಾಡ್ಕೊಂಡು ನೀವು ಅದೇ ತರ ಒಂದು ಕಾಲಮ್ ಹಾಕಿ ಇಟ್ಕೋಬಹುದು ಇದನ್ನ. Next one is Cartesian sign conventions. Cartesian sign conventions. Okay, we have said the same thing in case of mirrors. Okay, so ಇಲ್ಲಿ ಏನಾಗ್ತದ ಅದೇ ಕಾನ್ಸೆಪ್ಟ್, ಬಟ್ ಇಲ್ಲಿ ಅಲ್ಲಿ ಪೋಲ್ ಅನ್ನು ವರ್ಡ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ. ವಾಟ್ ವಾಸ್ ದ ಪೋಲ್? ಇಟ್ ವಾಸ್ ದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್. Instead of pole, here we are using optic center. Was optic center is a midpoint of the lens through which a ray of light can pass without deviation. So that is optic center. ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ ಫಸ್ಟ್ ರೂಲ್, all the distances must from the pole. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಫಸ್ಟ್ ರೂಲ್, all the distances must measure from the optic center. So ನಾವು ಯಾವುದೇ ಡಿಸ್ಟೆನ್ಸ್ ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೂ ಆಪ್ಟಿಕ್ ಸೆಂಟರ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕಾ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಐ ವಾಂಟ್ ಟು ಮೆಜರ್ ದ ಫೋಕಲ್ ಲೆಂತ್. What is focal length? The distance of the principal focus from the optic center. So again measure ಮಾಡಬೇಕಾ ನಮ್ಮ ಮೆಜರ್ಮೆಂಟ್ 1 2 3 4 5 6 like this from the optic center to the respective points. Okay, here for lens there will be two focal lengths. I want to measure the f here, focal length here. So 1 2 3 4 5 like this. I want to measure center radius of curvature for the first surface here, for the second surface here, like this. So our measurement must be from the O, that is optic center. Okay, and the second rule, this is same as in case of the mirror. Hengagtada. So all the distance or the distances, if the direction of measurement is in the direction of incident ray, we should take it as a positive. I call this is incident ray. This is incident ray. Now I want to measure focal length of this surface curvature, focal length of this curvature, or radius of curvature of this one. ಅವಾಗ ಏನು ಮಾಡ್ತೀನಿ ನಾನು? ಸೊ ಇದು ಮಾಡ್ಬೇಕಾದ್ರೆ 1 2 3 4 5 6 like this, and see my direction of measurement is in this way and the direction of incident ray is in this way. So the direction of measurement is opposite to the incident ray. So now we should take all these distances as the negative. These are negative distances. So which are negative distances? If the distances are measured in a direction opposite to the incident ray, we should take it as negative. If our direction measurement are in same direction as that of incident ray, if the direction of measurement is same as the direction of incident ray, we should take them positive. For example, I want to measure radius of curvature of this one. ಈ ಸರ್ಫೇಸ್ ಅದ ರೇಡಿಯಸ್ ಆಫ್ ಕರ್ವೇಚರ್ ಫೈಂಡ್ ಮಾಡಬೇಕಾ? ಅದೆಲ್ಲಿ ಇರ್ತದ? ಈ ಕಡೆ ಇರ್ತದ. ಸೊ ಐ ಸ್ಟಾರ್ಟ್ ಟು ಮೆಜರ್ 1 2 3 4 5 like this. Okay, if our direction measurement is like this, see here its direction and incident ray direction are same. So here we should take them as positive. Is it clear? So very simple. Then third one, and the third rule, if our direction of measurement are in upward direction perpendicular to the principal axis, we should take them as positive, and the downward distances perpendicular to principal axis, we should take them as negative. So these are three simple rules as a Cartesian sign conventions. Okay, the next one is general rules to draw ray diagrams. Okay, ಈ ಕಾನ್ಸೆಪ್ಟ್ ಮತ್ತೆ ನಾವು ರಿಫ್ಲೆಕ್ಷನ್ ಆಗೋ ಮಿರರ್ಸ್ ಅಲ್ಲಿ ಕಲ್ತಿದ್ದೇವ ಸೇಮ್ ಆಗಿ ಕಾನ್ಸೆಪ್ಟ್. whenever a ray is incidenting on the lens parallelly, so if you are having parallel incident ray, then the emergent ray, see the word I am using, emergent ray, not as a refracted or reflected, because here also it is a refraction and here also a refraction. Lens ಒಳಗೆ ಹೋದ್ಮೇಲೆ ಇಲ್ಲಿ ರಿಫ್ರಾಕ್ಟ್ ಆಗ್ತದ, ಗ್ಲಾಸ್ ಇಂದ ಹೊರಗಡೆ ಬರಬೇಕಾದ್ರೆ ಮತ್ತೆ ಲೈಟ್ ರಿಫ್ರಾಕ್ಟ್ ಆಗ್ತದ. ಸೊ ಅದಕ್ಕೆ ನಾವು ವರ್ಡ್ ಏನು ಯೂಸ್ ಮಾಡ್ಲಾತಿದ್ದೀನ, ಸೊ ದಿಸ್ ಇಸ್ ರಿಫ್ರಾಕ್ಟೆಡ್ emergent ray. And see, whenever the incident ray is parallel to the principal axis, the emergent ray must passes through principal focus. Okay, and the second rule, what I drawn here, this is principal axis. Okay, so whenever the light is incidenting on a lens through the principal focus, then the emergent ray, like this. How is the emergent ray? It is parallel to the principal axis. It is a reverse case of the first rule. So if incident ray is parallel, the emergent ray passes through F. If the incident ray is only passing through F, the emergent ray is parallel to the principal axis. And last one, in main paper, what I drawn, this is principal focus and this is optic center. And if a ray of light is incidenting or passing through the optic center, there will not be any refraction. It passes undeviatedly, directly. So this is the third rule. Henge third rule henge, optic central ray of light pass ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಹೋಗ್ತದ, ಅಲ್ಲಿ ಬೆಂಡಿಂಗ್ ಆಕ್ಷನ್ ರಿಫ್ರಾಕ್ಷನ್ ಇರೋದಿಲ್ಲ. Okay, so these are very important rules. Okay, now the ray diagrams. See the first one, when the object is at infinity, then the rays from infinite object, they will be parallel to the lens. They are parallel to the lens. Okay, and whenever the parallel lens incident on a lens, we know they must pass through F. Means all those parallel incident rays meets at F. So that's why the image forms at F. And here image is at F. And what about the size? Point object, and the nature is real and inverted. This is first case. And second one, if the object is beyond the 2F, it is beyond the 2F, this is the object AB, and where is the image? A dash, B dash is the image, where the image form is in between F and 2F. Okay, and how to draw the ray diagram? A ray from the object is incidenting on the lens parallel to the principal axis. By the parallel incidence, it has to pass through F. See here, it is passing through F, one ray, and another ray, it is from object and it is passing through O. So whenever a ray is passing through optic center, it will not suffer from the refraction, so it will pass undeviatedly, undeflectedly, so it will be a straight line. And a position where the two refracted rays meet, so that will be the position of formation of image. Okay, and see now the image is in between F and 2F. Next, what about the nature? It is real. What about the size? It is diminished. You can see the smaller size. And the third point, when the object is at 2F, say A, B, it is object, and the image A dash, B dash. Okay, when it is at 2F, so image forms on other side of lens at 2F only. And what about the size? It is same as that of the object, and you have written the image is at 2F, and its nature is real and inverted, and the size is same as that of the object. A ray is parallel, it has to pass through F, and a ray from optic center, so it is passing directly. So the position where those two rays meet, so that will be the position of the image. And the next point, when the object is in between F and 2F, see here, it between F and 2F, AB is our object, right? Where will be the image? It has to be beyond the 2f. Is beyond the 2f. A parallel ray and a ray from O, and they are meeting here. Okay, A dash B dash is our image, and it is a real inverted image. And what about the size? It is magnified. You can compare AB with the A dash B dash. You can say it is an enlarged image, right? And next, when the object is at 2f, when the object is at 2f, see here, sorry, between, when the object is at f alle object it will principal focus alli. So AB is our object, and the image forms at infinity, means those emerging rays, they are not meeting at a finite distance. So a ray, parallel line, it is passing through f, and it is through O, passing directly, and see here they are not meeting, they are moving parallelly. It means the parallel lines meet, we say the parallel ray may meet at infinite distance. Okay, so here image at infinity, and it is a real inverted image, and the size will be very, very large. And the last point, when the object is in between f and O, f and O means principal focus and optic center. So this is our object AB, and a ray parallel to this one, it is passing through f, and optic center, a ray passing through optic center, it will move undeflected, undeviatedly, it will move directly. And see here, these two rays never meet in this case. Okay, the emerging ray, they never meet in further distance. Okay, so if we extend them backward, so they meet here. So that's why the image appears to be on the same side of the lens. ಓಕೆ, ಸೊ ಇವಾಗ ಏನು ಅನಿಸ್ತದೆ ನಮಗೆ, ಇಲ್ಲಿಂದ ನೋಡಿದ ತಕ್ಷಣ ಇಲ್ಲಿಂದ ನಾವು ನೋಡ್ತಿರ್ತೀವಿ, ಇಲ್ಲಿ ನಿಂತ್ಕೊಂಡು ಆಬ್ಜೆಕ್ಟ್ ಇಲ್ಲಿ ಇರ್ತದ, ಇಮೇಜ್ ಇದ್ರ ಮುಂದ್ಗಡೆನೆ ಅದಕ್ಕಿಂತ ಮುಂದೆ ಬಂದಂಗೆ ಇಲ್ಲಿಂದ ನಮಗೆ ಕಾಣಿಸ್ತಿರ್ತದ. ಸೊ ದಿಸ್ ಆರ್ ದ ರೇ ಡಯಾಗ್ರಾಮ್ಸ್. ಸೊ ಯು ಮೇ ಗೆಟ್ a 3 mark or 2 mark question to draw the ray diagram in a particular cases of convex lens.